analog devices and circuit. Unit number 3, optocoupler and opto-isolator. Okay, so this is optocoupler and opto-isolator. The combined package of LED and the photodiode is called the optocoupler. It is also called an optocoupler or an optically coupled isolator. So the source V1 and the series resistance R1 decide the forward current I1 through the LED. Thus, LED emits the light. This light is incident on a photodiode due to this. A reverse current is set up in the current circuit. This current produces a drop across the input resistance R2. The voltage, output voltage is the difference between the supply voltage V2 and the drop across the resistor R2. The V out is equal to V2 minus I2 into R2. Now, if input voltage is changed, the amount of light emitted by the LED changes. This varies the reverse current in the output circuit, hence the output voltage. The output voltage varying in step with the input voltage. The coupling between the LED and the photodiode is hence called optocoupler. As the name suggests, this device can couple an input signal to the output circuit. Okay. So there is a model which are used for the optocoupler. That is, we have source V1 and V2 in the output. That is, V2 as a load. So transmitter is LED and receiver is photodiode. So by changing the intensity of the LED light, the output photodiode will vary the depend on the LED light. So let's see this diagram. So in this one, so when the light is enabled, so the motor will be enabled because this electrical current that is like isolator will given to the photodiode received by the photodiode. The output is enabled. Okay, that is the output loop will be closed by the photodiode load. So when the input voltage forward bias, the LED light emit transmitted to the phototrons into the arc. So resulting the current through the external load shown in the above figure. So there are two types of optocouplers are available by using of transmitter and receiver. One is LED photodiode and one is LED photodarling. In the both the circuit, the input current which is forward current of LED result in the emission of light LED. This light is detected by the photodiode and the photodarling to produce the output current. So these optocouplers used in the many of the applications. The ratio of the output current of the LED and IL is called current transfer ratio. That is output current divided by input current. The CDR is CDR means current transfer ratio is different for different optocoupler as indicated in the different indicated for the different devices. Photodiode having 0.01 to 0.01. That is LED Darlington will be 1 to 5. So there are different characteristics of optocoupler. Why we go for characteristics? If you want to know the characteristics of the different photodiode means you can easily judge the photodiode for the for optocoupler for the particular application. That is, these are the following characteristics. That is current transfer ratio, isolation voltage, response time, common mode rejection ratio, then bandwidth like that we have. That is current transfer ratio. We know that output current divided by IC divided by F into 100%. Then VISO, that is isolation voltage between the input and output. Then response time. The response time of the optocoupler depends mainly on the output phototransistor. The response time also depends on the input forward current and load resistance. Since load resistance has a greater influence on the response time, so careful setting is required while defining the circuit constant. So the optocouplers output is electrically isolated from its input for relatively low frequency signal and perceives signals. So this is the monolithic IC for the optocoupler, that is MC2E or MCT2. So in this IC, they have a different couplers and the n number of couplers they have. So advantage of optocoupler, the response time of the optocoupler is smaller than KND, used to transmit the data, capable of wideband signal transmission, compact and lightweight, much faster than the isolation transform and the relays. Okay, thank you.